Welcome back to Train Signal. This is Elias Knaser, and you're watching Introduction to Cloud Computing. Boy, are we really going to do this? Are we going to talk about cloud computing? Cloud is probably the most debated, most controversial concept or term that's ever existed in the IT industry, in the IT world. There's so much confusion around cloud that it's very hard to define it, right? You put 10 people in a room, you ask 10 people, you're going to get 10 different answers about what cloud computing means. Now, in the early stages, cloud computing was essentially just a marketing scheme where it would allow you to repackage certain products and just resell them with a sexier technology. However, with the progression, with the evolution, cloud computer finally has context. It has construct. We can define it. We can talk about it. We can build it. And that's what we're going to do in this course. We're going to do it from Microsoft's point of view. We're going to focus on the Microsoft private cloud. But what I want to do in this opening lesson is to define cloud computing in general terms, talk a little bit about it, and then as we progress, you'll slowly start to put the pieces together and understand what cloud means. Now, here's what I'm going to say about this lesson and some of the future lessons. In order for you to understand the concept of cloud, it's going to take a few lessons before this thing actually clicks. There's a lot of moving parts. There's just a lot of things going on, and it's going to take a little bit for us to wrap our heads around, well, what does it mean to deploy a cloud, and how is my cloud different than my data center or my virtualized data center? So it's going to take some time. Bear with me, but I promise this is going to be one of the best courses that you've ever taken. So what is cloud computing, right? So when I rated the internet in order to find you a good definition for cloud computing, I came across the one from the National Institute of Standards and Technology. What better authority to define cloud computing than that, right? So they define cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to shared pool of configurable computing resources. Example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Eli, what did you just say? So one of the things that I want you to do, because this is a very good definition, is to read through this definition again and stop at keywords. Because if you stop at these keywords and start to analyze them, you'll start to understand what cloud computing means. So let's go through this again, right? So cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Let's take the keywords here. So convenient, on-demand network access, shared pool, configurable computing resources, right? So what do all of these mean? So convenient, I want to be able to do it on my own term when I want to do it. I want to be able to consume something maybe at 3 o'clock in the morning without having to go through my administrator, and that's where on-demand network access comes into play. So it's convenient, so it's on my own terms. It's on-demand network access, so it's when I want to access this. And then I have a shared pool of configurable computing resources. So what that means is it's a self-service portal. You have access to catalogs. You can deploy virtual machines. You can deploy templates. You can deploy services. It's on your own terms that you're doing this. And we're talking about this through the constructs of networks and servers and storage and applications and services. So all of these come together in order to form that convenient on-demand access that I want, right? Now that can be rapidly provisioned. Rapidly provisioned means if I want to do this at 3 o'clock in the morning and an administrator is not there, I should be able to do that. That's when I want to consume this. And released with minimal management effort, which means if my cloud is configured properly and the security policies are in place, I should be able to provision, request things, and go through the management layer that is policy driven, where policies have been pre-configured, where I can't go outside of these policies, right? And if I meet or if I adhere to them, then I should be able to receive the service that I'm requesting from this cloud without my service provider interaction. Now, the service provider here can be your IT department, which is us, right? It can be a service provider maybe in the cloud like an Amazon Web Services or a Terramark or any of the other cloud providers that are out there. So service provider here, don't think of it just as something that you as the IT person would consume. Think of the service provider here as what your users are looking at you to be. You are the service provider to them. You are providing that service to your users. Now, the cloud model is comprised of 5 essential characteristics, 3 service models, and 4 deployment models. And in order to look at these service models and delivery models, or the essential requirements, let's take a look at, well, what are some of the characteristics that are going to constitute a cloud? What do I need before I can say, okay, well, I have a cloud? Well, number one, you need some kind of self-service, whether it's a portal, whether it's a management console, whatever it is, but the user that is requesting the service or the virtual machine or the application, they have to be able to be self-sufficient. They have to be able to do stuff, to consume stuff without having to go to you every time and ask for things. Now, why is this important? This is important because in the technology world today, technology companies are no longer marketing to us administrators or us IT folks. They are going directly to the consumer. They have a bigger market with the consumer. Now, what did that do? Well, that started to educate the users that they can consume services in a different way. Take your credit card, swipe it, ask for a virtual machine with X amount of vCPUs, some memory, and voila, you're up and running in a matter of minutes. That's putting pressure now on IT departments to have that similar model that their user community can also consume. Because users are so used to now just consuming whatever they want to be able to do the same thing in their organization. So that's where a self-service portal exists, right? You are providing them with a catalog of services that you offer. You are then becoming the service provider saying, hey, I have VM1, VM2, VM3, or you can customize your VM, and here are the boundaries of what you can customize it with. You can have 1 vCPU to choose from, 2 vCPUs, 3, etc. Build your own essentially, and here's how much it's going to cost you. So that's your self-service portal. You have a resource pooling, right? So you want to be able to pool your resources together so that you're creating that elastic cloud, so that you're able to, not every time you want to create, for instance, storage, you have to go in and create a LUN and then create a data store. You are pre-provisioning a lot of that stuff. You're pooling your resources, your hardware resources together and providing them as something that they can consume. And then you have that elasticity that comes out of that resource pooling, right? So you can stretch those resources. So if somebody wants 500 gig hard drive, well, it's available to them. They want 4 vCPUs, it's available. You can quickly add to your hardware without affecting them or without being obvious that you are doing something in the background. You have these resource pools. Every time you want to add more storage, you're just dumping it in the storage pool. You're adding more compute. So you're creating that elasticity in your infrastructure. And then everything is policy based. So you have to do, so one of the things that you're going to notice about cloud computing is there's a lot of work that you're going to have to do up front. You're going to have to put in those hours in order to configure everything. There's a lot of minute details, and you're gonna see this throughout the course that you have to do. It's no longer as simple as it was before. Right-click, create a VM. There's a lot of homework that we have to do ahead of time so that later on our cloud can self-manage itself. But in the beginning, as we're building it, it's going to take a lot of resources on your end. It's going to take a lot of thought. You have to put a lot of thought process into it, into designing it, into designing your process, your automation, your release, etc. And then we're going to talk about metering. So I've built this cloud, and now cloud presents an opportunity for us as an IT organization to transform from a cost center on the business to a service center for the business. I can now go to those users, those business, those department owners, their application owners that are consuming my services and charge them for the service. They no longer can say that, hey, IT's cost, I just keep dumping money into it. No. You are consuming these 5 services, and these 5 services are, made up of these, 25 virtual machines. Oh, and by the way, my cost is X per VM or X per service, so please pay me based on what you're consuming from me. So in order for me to maintain the level of service that you are adapt to. So you are transforming IT with a cloud model from a cost center, from a burden on the business, to a service model, to something that you can now go out and charge for. If they're expecting to swipe their credit card and get a virtual machine from Amazon Web Services, then it should be no different if they are trying to consume services on your internal cloud that is also associated with a cost. Now, keep in mind that a lot of the accounting practices are not apt, they're not used to that type of model, so that's going to have to progress slowly within IT organizations. Maybe you'll start with the showback. At least you can justify what they're using and then slowly build that into the accounting processes. So the point I'm trying to make from all of this today is that when you start going down the path of cloud, private or public or whatever the case is, you're going to find yourself involved in the business process more so than before. You are no longer going to be just the technical person playing around with a server or a switch. You are now going to be involved in the provisioning and the acquisition of applications and accounting. We're talking about metering. It is your responsibility now to figure out how to get the accounting system to be able to adopt to a chargeback or at least a showback model. Now, there's three service models that typically are involved with clouds in general. You have infrastructure as a service, and we'll talk about what that means in a second. You have platform as a service, and then you have software as a service. What you're going to notice, as we start to talk about these different service models, is every time you go higher up the stack, you're going to find another abstraction layer. So what does infrastructure as a service give us that virtualization didn't give us? So in a virtual world, and I have some diagrams to showcase that for you, we abstracted the hardware and created virtual machines. Great. In an infrastructure as a service, we are now abstracting the manual process of creating these virtual machines and moving up a level to creating services. So for instance, a service could be made up of a web server, a SQL server, a file server. These three collectively make up, for instance, the Citrix service, for instance. So in infrastructure as a service, you're creating all of the self-service, the automation, everything that we just discussed on the left here. You are building that into your infrastructure that was not previously available. Now, when you elevate it one step up, and now we're talking about platform as a service, well, platform as a service completely abstracts all of the hardware. You are no longer dealing with any kind of hardware. You're no longer dealing, for the most part, with the purchase of hardware as well. You're dealing with, these service providers that are providing you with a platform that you can develop your applications directly against that platform. And that platform has policies, has constructs, has APIs in place to take advantage of a lot of things. For instance, BCDR will be built in to a platform as a service. For instance, this is, I'm giving you an example of what a platform as a service can be. So you're elevating yourself and no longer dealing with the infrastructure, you are now dealing with the application development. And then the holy grail of cloud computing model is the software as a service. The software as a service, and it's typically for software development companies, is when you're delivering this application to the users that can consume it, and you are completely abstracting everything, including the development. This is an end user consumable product at that point. I don't foresee a lot of organizations, a lot of enterprises being able to deliver homegrown applications in the form of a software as a service, just because of, if we're going to adhere to the authentic nature of software as a service and, building the application around software oriented architectures. There's a lot that goes into that, but the idea here is infrastructure as a service. It's all about automation, orchestration of very highly virtualized environments, taking into account what we just talked about here on the left. Platform as a service is essentially a platform that abstracts all of the stuff in infrastructure as a service and delivers a platform for developers to be able to code directly against. So you are now giving them the .NET that's already installed, SQL's already installed. All they're doing as they're coding their application is saying, okay, I need some database services, I need some .NET services. They're just grabbing services that are required for their application without needing to install and configure a SQL server and figure out what type of RAID groups to put under it. None of that. And then software as a service is the ultimate in that, where you're just delivering that application to your users. Now, there's also a couple deployment types for cloud. Now, private clouds are typically, they're associated with infrastructure as a service. I'm not saying that you can do a platform as a service in the form of a private cloud or software as a service for that matter, but I'm talking in a traditional enterprise IT, you'll find that a private cloud is most closely associated with infrastructure as a service. Platform as a service and software as a service are more for software companies, the likes of Zynga and Netflix and these guys that are going to be able to build these models for their customers to consume. A hybrid cloud is the ability to connect a private cloud to a public cloud in order to extend your resources, maybe burst. You have that extended capacity so that if at the end of every month maybe you need an extra boost, you don't have to go out and buy more resources, you can just burst into the public cloud. And the public cloud is self-explanatory. It is where you're consuming resources from a third-party service provider, but you're bridging that through connectors and extending your network in some cases, or you're building your entire infrastructure, entire virtual infrastructure on someone else's public cloud while controlling it and managing it from the comfort of your own desk. Let's talk about the evolution, right? So back in the day, we started off with mainframes. Mainframes then took us into client server. Client server then took us into web. Virtualization is that jump between web and cloud. That's the gap. That's the bridge. That's how we're going to create these infrastructures in our data center that are not traditional client server anymore, and there are not software-oriented architectures like the SaaSes of the world. Through virtualization, we're able to bridge the gap and create that infrastructure as a service environment, that elastic environment that we've been talking about. So cloud computing will transform the delivery and consumption of IT services. So it's not just the delivery, but also how we consume IT services. All of that will change through cloud. Whereas virtualization, we just abstracted the hardware, but the same practices were inherited. We didn't really change anything. Cloud changes the behavior, the consumption, the way we deliver IT changes. So a lot of different components, a lot of different moving parts there. So let's talk a little bit about what it looks like, right? So in the beginning, you had the physical rack. This physical rack had your network, had your storage, had your servers. It was just basically racks and racks and racks, hundreds of these in a data center that constituted your data center, right? Now, virtualization came along in VMware, and we started to see these racks kind of, you're able to use them more efficiently. So that one rack now had maybe multiple racks in it. You started to abstract the hardware and leverage this hardware, take advantage of it. So unused resources here, we were able to take advantage of unused compute resources and be able to put 40, 50 virtual machines on a single hardware. So this one rack that supported maybe 15 or 16 or 20 blades with networking and storage, all of a sudden that one rack, now when it was fully populated, you get hundreds of VMs. So you were able to leverage that from a virtualization perspective. So what virtualization gave you that was different from physical, we inherited the same types of business processes, the same business model, the same consumption model, but we became more efficient at it. But our delivery was the same and our consumption was the same. It was just instead of installing an operating system on top of physical hardware, we are now installing operating system and applications inside of virtual machines, and that brought us a lot of ease of movement, a lot of agility. But our processes, our delivery mechanisms, our consumption models never changed. They were all the same. Somebody wanted a virtual machine, well, now they're getting a virtual machine instead of a physical machine, but they had to ask for it. They had to go through the same hooplas. In some cases, they had to still buy it. So again, nothing changed in that model. Now we move to infrastructure as a service, and you notice that the data center is now kind of cloudy, right? So we no longer have those physical constraints. We are starting to think more elastic. We're starting to think different consumption model. We're starting to think self-service portals. We're starting to think policy-driven. We're starting to think resource pooling. So all of the things that you didn't think about from a virtualized perspective, you've now been elevated one step higher to automation and orchestration and different consumption models and different delivery models with an infrastructure as a service. Now, if you move here to the right to the platform as a service, what do you notice? Well, you notice that the infrastructure is kind of gone, and the focus is now on development of these applications. So we are completely abstracting the complexity of the infrastructure, the pooling, all of that, and we're essentially delivering a platform for the developer to be able to code against. Here's a platform, here's everything that you need on it. Here's your database services, here's your web services, here's your file services. Just take what you need, and it's in the form of a service for the application. And then you have the software as a service. That would be the outcome of what the platform as a service is providing for developers. The outcome becomes a software as a service delivered application. So let's take a look at what enterprise data center looks like versus what cloud looks like. So in enterprise IT, the whole idea was to scale up, right? So when I was in enterprise IT, we would purchase for the maximum capacity, right? So we would, we would have our budgets and everything, but we would purchase the maximum capacity. So if somebody wanted 500 gig, we would probably buy 2 terabytes because that was, the maximum that we were going to go to. And we would take our time deploying it. And then when we were out of capacity, then we go through the cycle again of, requesting money and then buying another maximum and so on and so forth. So that was scale up. With cloud, we're scaling out. So we're changing the way that we are handling resources. We're no longer thinking of, well, we're going to build to the max. There is no max. The cloud is a moving, elastic entity, if I could call it, that you can constantly add to in a very seamless manner. Now, in enterprise IT, we would build things to assume reliable infrastructure. Now, what do I mean by that? Well, when you're deploying these applications, when you're deploying these servers, you're either doing HA, you're doing clustering, you're doing replication, you're doing everything for uptime. Downtime was completely unacceptable. It was a bad thing. You're building an infrastructure essentially that never fails. When you look at cloud, the infrastructure in cloud is expected to fail. But because of the nature of cloud, because of the redundancies that are built into cloud, because if your developers have built their applications properly, then essentially that application should never fail. I'll give you an example. When Amazon took an outage a couple of years ago, and Netflix, for those of you that don't know, Netflix is completely built on top of Amazon Web Services, or for the 95% of it is on top of Amazon Web Services. So when a large portion of the Amazon cloud took a hit, Amazon East I believe it was, Netflix had a degraded performance delivery for their customers, but they never took an outage because their application was built in such a way to understand that I might see a problem, I might have an outage, and they've built around it. So they've leveraged the platform to take into account outages. So what we're going to do when we're transforming from enterprise IT into cloud is, as we're building our clouds, as we're putting together the services, as we're constructing it, we're going to build it in such a way that if I have, for instance, a 3-tier service made up of a web server, a SQL server, and a file server, and one of them takes a hit, I should be able to sustain that. Now again, we're probably going to be doing a lot of the same similar things that we were doing in enterprise IT with clustering and load balancing and all of that. But again, we're doing it in an abstracted manner, in an automated manner. We're leveraging the ability for the cloud to automatically respond to things that we would traditionally have to do manually. Maybe a failover cluster, we would have to initiate the failover cluster, for example. I know that's automated, but I'm giving you an example. In the cloud era, maybe if you have a load balancer that's deployed and it took an outage somewhere, it's automatically going to provision new virtual machines because it knows that, okay, well, I took an outage on the east side, but I have more resources on the west side here, and I'm starting to see a degradation in service because I have a lot of users and I can't service them. I'm going to automatically spin up virtual machines here or services in order to backfill for what's going on the east side. Now, again, this is the cloud responding to a degradation or a service level agreement that went down. It's responding automatically to that, whereas all of this used to be manual in enterprise IT. It's also high cost, right? So everything is very, very expensive. We're buying very, very, very high-end stuff. It's high cost because we have to do everything. You need an administrator. IT management, for instance, the second point here, IT centric. It's one administrator for every 100 servers. It's typically the rule of thumb. Whereas when you switch it over to the cloud, you're starting to see self-service experience. So once you've set it up, once you've gone through the hassles and set up your cloud, well, the user doesn't need you to create that virtual machine or deliver that service anymore. That service is available on-demand self-service experience, so you've just freed up a lot of the time that your administrator had to spend configuring or delivering some of these services, some of these applications, which means instead of hiring 5 people now, you're able to maintain the amount of people that you have, but you freed up their workload. So you have a lot of automation, and one administrator can now manage thousands of virtual machines and services as opposed to hundreds. You had fixed costs in enterprise IT. Fixed costs, well, that meant, I'm buying this storage array, I'm buying these servers, I'm buying this network, and this is how much it cost me. You had a bill of material, right? Well, there was really no way for you to justify this. That's why we were always looked at as a cost center. Everybody kept dumping money, and they didn't see, well, where was that money going? What is that money giving me? So we looked at the business, so look at these guys. They don't know what the heck they're talking about, right? We're doing all of this for them, but there was no way for them to actually appreciate what we were doing. So what does cloud do? Well, cloud changes the consumption model to a usage-based cost. Well, Mr. CFO, you're going to give me $1 million, and guess what? Here's what I'm going to build for you, and here's the menu. For your customers, for your users to consume my IT resources, here is how much it's going to cost you. This is your $1 million, and this is what I was able to build. I am building a business within a business. I'm not a cost center. I'm actually a profit center. And if I'm not a profit center, I'm just, I'm a break-even center for the most part. Now you've given the business reports they can understand. Now they can make sense of it because it's dollars and cents. You are also charging for your services, and why not? The business is hiring you for your intellectual property, for your capabilities. That doesn't mean that you as an IT department, not the individual, the IT department, should be a cost center. You have a service, just like accounting has a service and marketing has a service that they deliver to the company, where they're able to quantify it and justify it. So does IT. IT also can quantify and justify their value to the business now through usage-based costs. So you think you know private cloud? Those of you that are so far, I know private cloud. Let's take a look at some questions. I would like you to answer these questions, and then let's see, they were right or wrong. So virtualization is private cloud. I hear that all the time, and I want you to pause the video. Think about this for a second. After everything that I've talked to you about so far, do you still think that virtualization is private cloud? Well, the answer to that is false, obviously. Virtualization, again, abstracts the hardware from the software, and it gives us a lot of flexibility in terms of dealing with virtual machines instead of physical machines. We're maximizing the usage of unused compute resources in the past, but virtualization brings the same types of processes, the same types of exercises that we would do in the physical world. Again, simple example, instead of installing an operating system and applications on physical machines, we're doing it on virtual machines. Instead of clustering it using physical stuff, we're doing virtual stuff. Instead of replicating the SAN, we're now able to copy and paste, for example, virtual machines if we wanted to. But our processes were the same, we were looked at the same, very little automation, if any at all, and essentially that's what we gave. Private cloud changes that. Private cloud is when you're getting into infrastructure as a service, into the automation and orchestration, into the ability to have that elastic cloud, into the ability of having that cloud respond to the SLAs if those SLAs go below what you're expecting. There's a lot of automation in private cloud. So if I was to simplify it, then cloud is that automation of processes, automation of infrastructure, and automation of deployment and self-service. System Center Virtual Machine Manager is a private cloud. Anyone? Now, we haven't covered this yet because we haven't talked about the Microsoft Private Cloud. But I wanted to put that here anyway because I wanted to see how much you knew. So, yes, no, false, true? Well, System Center Virtual Machine Manager on its own is not a private cloud. System Center Virtual Machine Manager is a component of the Microsoft Private Cloud, and I will show you later on what are the different components that make up the Microsoft Private Cloud. Now, Virtual Machine Manager, or VMM, is an essential point. It's a focus core point of the Microsoft Private Cloud, but alone, it's not a private cloud. Alone is just a management interface, just a management server. The private cloud is a product. This is an interesting question. Think about it before you answer this. False. There is no single product that you can purchase and say, I have a private cloud. A private cloud is a collection of products that have been masterfully configured and brought together to deliver a service. So instead of thinking of the private cloud as a product, think of it as a service. It's a collection of services that come together to offer a technology that is consumable to an end user. VMware vCloud is a private cloud. Yes? No? False. VMware vCloud, similar to System Center Virtual Machine Manager, cannot form a cloud on its own. Now, in the case of VMware vCloud, and I'm talking about vCloud Director here, vCloud Director is a product. Alone, it can't form a private cloud. Collectively, with other VMware products, they can form the VMware Private Cloud, or now called the Software-Defined Data Center. And I'm going to show you also a little later on in some of the other slides what a VMware Software-Defined Data Center or a VMware Private Cloud looks like. So the VMware vCloud Director is not a private cloud. The vCloud Suite is VMware's way of productizing cloud. For instance, they have different levels of cloud, but to get the cloud you need a collection of several different things, and we're going to take a look in a second. So traditional versus virtualized stacks. Now it's important here to talk about this, just to take you down memory lane, nothing else, to take a look at what was the difference, right? And I've been talking about this, and I wanted a way to visualize it for you. So in the traditional stack here, again, we had physical hardware, an operating system, applications. That's what we did. The virtualized stack, well, what did we do? We just abstracted the hardware, but all of our practices remained the same. See, that's essentially what I wanted to show you here. This is a virtualized stack. You can add SRM and some of the other bells and whistles to it, but at the heart of virtualization, that's the only difference. We are now able to leverage underutilized hardware, turn them into virtualized entities, and manage them in a better way. So what is a private cloud? A private cloud is a new model for IT delivery, right? It turns a data center's infrastructure resources into single compute cloud and enables the key benefits of public cloud computing. So public cloud computing is based upon pooled resources, self-service, elasticity, automated elasticity, automation, usage-based. All of these are things that you are used to in the public cloud. When you go out to consume something, we are bringing that to the enterprise data center. And as a result of these things, you are transforming your enterprise IT model or enterprise IT delivery model into a new type of delivery model that you can now charge, you can now justify. The Microsoft Private Cloud solutions are built on Microsoft Windows Server and System Center technology, and we'll talk about what that means. A Microsoft Private Cloud enables on-demand delivery of applications as standardized IT services. So one of the things that's a difference between how Microsoft is looking at private cloud and how VMware is looking at software-defined data center or private cloud. Microsoft is taking a very application-centric approach, whereas VMware is taking a very infrastructure-centric approach. Now, I'm not going to say that one is more right or one is right and the other one is wrong. It's just a different way of looking at the private cloud. Your job as you're evaluating this for your enterprise is to take your existing business model, take your knowledge, what you've collected over the years, and understand, well, which one fits me better, which one is technically viable after you've done your research, and take that approach. I like the Microsoft Private Cloud approach a lot from an applications perspective. I think the System Center and everything that we're going to talk about is extremely powerful, But I also like what VMware is doing with their software-defined data center. I won't deny that. But I can clearly see the differences in the approaches here. So, isn't virtualization a private cloud? No. This is a common misconception. Virtualization is a critical component, obviously. It gives you server consolidation, it gives you easy deployment, elasticity and scalability, multiple tenants, high availability and mobility, right? Private clouds provide more. They give you pools of compute resources, self-service provisioning, right? I don't need anybody anymore. Usage-based chargeback. Again, elasticity and automation throughout the stack, not just compute. I'm talking about elasticity and automation at the storage level, at the network level, not just at the compute. So that's another very important thing. Virtualization, server virtualization, did a great job virtualizing the compute for the most part. But now I want to do the same thing for the network. I want to do the same thing for the storage. I want to do the same thing for the applications. How do I do all of that? So let's take a look at a private cloud architecture. And this is not a Microsoft, this is not a VMware, this is just a construct of what a private cloud architecture could potentially look like, what a standard would look like. So let's go through this real quick. You're going to find that at the bottom here, you have your physical infrastructure, you have your virtual infrastructure, and you have your management layer. So these three layers, if I was to put them in, this is virtualization, right? This is your servers, your storage, your network. This is your hypervisor. Think about it, vSphere or Hyper-V, vCenter or System Center. Again, traditional virtualized stack. Now we start going up, right? We start adding things on top of it. Now we have chargeback. Ooh, now we're starting to talk about private cloud. I can justify my existing. Policy-based, resource allocation. This is something I don't have here. Performance optimizations. These are automated performance optimizations based on SLAs that you put together that the cloud can automatically react and backfill for itself. Lifecycle management. Today, one of the biggest things with virtualization is VM sprawl. Well, in a private cloud, you have lifecycle management. You have the ability of expiring a VM, the ability of checking out, checking in a virtual machine. You have change management. Change management based on idle processes and all sorts of stuff is built into a private cloud. Again, you notice here how there's a lot of different components, how you as the administrator now have to deal with more than just what you've been used to from a technology perspective. We used to be at like kids at Toys R Us. Here's toys, play with them. Well, now we're expected to elevate our game significantly. You have capacity management in a private cloud that also happens automatically because it's telling you when you're going to run out of capacity. So you're able to manage that capacity more efficiently. On the right here, you'll see that we have your public cloud connector, right? So this is where hybrid cloud comes into play. How do I take what I've just built and connect it into public cloud in order for me to boost? That's where your APIs, your connectors come into play. You have orchestration. How do I orchestrate across the different silos, not just on the compute? I want to do that on the network, on the storage. I want to do that across. And then you have your infrastructure authority, your management, your single pane of glass. Who's going to be telling all of these components to work together? On the left, you have your centralized management, and you also have your identity access management. Those are your role-based access, etc. What do we have up here? We have your service catalog. We have self-service portal. This is where you say, okay, well, this is what I have to offer you. Self-service portal, and here are all of your consumable services. This is what you are offering to your end users. You are putting that together and you are offering it to them. Whether that service catalog can be a single VM, a collection of VMs known as a service in the Microsoft world, a little more basic with VMware, known as VApps, but the services that we're going to talk about in the Microsoft private cloud are significantly more elaborate. So one of the other things that I've always been asked is, the cloud is a threat to my job. No, it will make your job better. If you think of the cloud as a threat to your job and you fight it, what's going to happen is, look, you're not going to stop technology. You can delay it in your organization. Be aware of what I just said. You can delay technology within your organization only. You can't delay technology outside. So my advice to you is to embrace it, is to learn it, is to find out where your weaknesses are, where your strengths are, and to enhance where you need to enhance. More time on improvements, not repetitive maintenance. So one of the things that we do a lot today is repetitive maintenance. We're just doing the same thing over and over and over again. And I'll be honest with you, that's made us lazy. Oh, I'll do that later. Because you know how to do it, you don't need to research it anymore. You do it at 3 o'clock in the morning. You'll slack around all day long. So when you're building your private cloud and everything is automated, that frees up your time. You're automating the solution to recurring problems, faster response to business needs. You're creating new services and value, clear and regular reporting, simplify management, and more variety, right? So it gives you time to learn more, to become more involved in the business. If you want to be effective, if you want to become harder to replace, you can't just be another IT guy. You have to be an IT guy with a sense of what the business needs, and you are delivering that service to the business through its business needs, not through the technology needs. So I've always lived by the mantra that there are no technology projects, there are only business projects. If you have that mindset, that mentality, you'll find that with a private cloud now you have to learn ITIL, change management, right? Now you have to figure out project management. You better be darn good at it. You are now going to learn how to influence the business from a chargeback and showback perspective so that the accounting practices are changing. You're having a different conversation with your boss. You are no longer the techie. You are now the business savvy techie that is thinking about things from a business perspective. Move from generalist to specialist. Become more important to the company. That is crucial. That is my advice to you. All right. So what I want to do, I want to end this lesson hopefully on a high note. Hopefully you have a really good idea of what cloud computing means, and this would lay the foundation for our next lesson that's now going to talk about the Microsoft private cloud and what does that mean, what do all these components mean in the Microsoft stack. So again, what do we talk about in this lesson? We talked about some of the concepts and principles of cloud computing. We discussed the different service models and the different delivery models. The service models are the infrastructure as a service, the platform as a service, the software as a service. The delivery models are private, hybrid, public. We talked about the fact of what constitutes a cloud, right? Resource pooling, elasticity, self-service, provisioning, automation, orchestration. We talked about all that and laid a good foundation for what is cloud computing, what is the difference between a traditional data center, a virtualized data center, infrastructure as a service data center, platform as a service data center. Hopefully you have a good understanding of cloud computing now. There's no more confusion, and we can start building on top of this in order to move forward. Finally, I hope you enjoyed this lesson, and I'd like to thank you for viewing.